So in part C, we are given that the integral from 0 to 4 of the f of absolute value of x is 1.6. So if we were to draw it on the original graph, it goes something like from here to here. So this area, so the integral from here to here is 1.6. And then in part 1, we need to find the integral from -4 to 0 of f of x. So we simply have to look at the graph and see where this is. So if we go from here, like about here again to -4, we need to find the integral of this. And well, we can see that it's the exact same areas as in the first part. It's just on the negative side. So this will simply be -1.6. And in part 2, we need to again find the integral from -4 to 4 of the sum of two functions. So the first function is f absolute value x, and then the second function is just f of x. So we can look at these separately as their limits of integration are the same, so we can split it up into two sums. And so we can write this as integral from -4 to 4 of f absolute value x dx plus integral from -4 to 4 f of x dx. So we can evaluate them separately, and what we see is that the integral from -4 to 4 of f of x, that's like looking again at the graph from part B. It's like doing the integral from -4 to 4. So if we look at this area over here and we add these two areas, it will be 0. So integral is always the signed area. So area underneath the x-axis is considered negative. And we can see that these two cancel each other out. So this will in fact just be 0. And then for the absolute value of x from -4 to 4, well, that's just considering from here and the other side as well. So we simply have 1.6 two times, as it's symmetrical about the y-axis. So we have 2 times 1.6, which is 3.2.